All right, today we're going to be looking at 3.8 implicit differentiation. First, we have a definition. So as you go through the textbook, it kind of explains why we're doing implicit differentiation. But it tells you that for some equations, such as x squared plus y squared equals 1 or x minus y squared equals 1, it is possible to solve for y and then find the derivative. But even in these cases, it says explain why implicit differentiation is usually a more effective method for calculating the derivative. And if we go through our choices, A, it gives a single unified derivative, although some of these other things might be true. In some cases, they're not always true. So we're looking for unified derivative. Now, number 2, we want to actually use implicit differentiation to solve. Now, I want to show you 2 methods. Okay, moving forward, I'm going to do whichever one is easier, but you do need to kind of be familiar with both. I'll probably show you twice. All right, we're going to start out with, it's a little bit off. We're going to start out with 36x equals y squared. Now we are taking the derivative with respect to x. So when I take the derivative of the variable x, I just take the derivative as normal. Whenever I take the derivative of y, I have to also treat it like chain rule, and I'll have a dy dx. So when we do derivative of a constant, okay, power rule, 1 times 36 will give us 36. Subtract 1, that'll give us x to the 0, which is 1. And then when we do the derivative of y, we do power rule, 2 times the 1 out front is 2. This is like the inside, 2y, subtract 1. So this leaves us with a power of 1. That's the outside. Now the derivative of the inside, derivative of y, with respect to x, we write dy dx. Okay. So at this point, we are now going to solve for dy dx. That just means I need to divide off the 2y. So if I divide by 2y, 36 divided by 2 is 18 over y equals dy dx. Okay, you can rewrite it the other way. You can say dy dx, because we're used to having it on the left side, is equal to 18 divided by y. Now, this is our derivative. The second method is an advanced method called partial derivative. Okay, it looks like almost like a 2, okay, but it's like it's not finished. To do the derivative with implicit differentiation, we do the negative of the partial derivative with respect to x and a partial derivative with respect to y. So that means if we take this function, first we want to set it equal to 0. So 36x, we would subtract the y squared equals 0. So when we say partial derivative, we're going to take the derivative of just the x, treating y like a number, like a constant. And when we take the derivative of a constant, we get 0. So once we set it equal to 0, derivative of x would be 36. Now I have a negative out front, so this is going to give me 36. Okay. That's the partial derivative of x, just 36. Derivative of this would be 0 because it's a constant. And then we take the partial derivative of y. So now we're going to just focus on y. So when I take the derivative of y, it's a negative here. We're going to get a negative 2y. Negative divided by negative is a positive. And when we reduce 36 divided by 2, we still end up with 18 over y. And so if you like that method, you do feel free to do it. Either one, we're going to get 18 divided by y.